Welcome to This Explainer. If you've spent any amount of time doing academic research, you absolutely know the feeling. You type a few keywords into a database, hit enter, and instantly find yourself drowning in literally millions of search results. Most of them are completely irrelevant, and the sheer volume is frankly enough to make you want to give up before you even really begin. Well, today we are going to fix that. We're diving into a masterclass on the Advanced Search Interface in Web of Science, which is an incredibly powerful tool designed to give you absolute control over your bibliographic searches.
Let's be honest, tackling a massive literature review can feel a lot like an epic quest. And in this scenario, that giant, unstructured mountain of irrelevant papers is the monster blocking your path. To defeat it, you can't just swing wildly with basic keywords. You need real precision. You need the right syntax weapons. In this explainer, we're going to acquire the exact codes, symbols, and logical connectors required to slay that monster so you can extract only the highly relevant research you actually need.
All right, here's our game plan for today's explainer. We'll start with beyond the basic search, then cover field tags and wildcards, mastering Boolean operators, proximity and nesting, and finally, building complex queries.
Okay, let's kick things off with Section 1, Beyond the Basic Search, and what we call the precision problem. Throwing simple keywords into a massive academic database is literally like walking into a giant library and just shouting a word out loud. You're going to get a lot of noise, but not necessarily the exact book you want. Just look at the stark contrast here between scanning broadly and commanding the database exactly where to look. A basic search just blindly scans general fields like the title, abstract, and keywords all at once. Advanced search, on the other hand, puts you entirely in the driver's seat. It allows you to define exactly which specific field to search, how to logically combine your search terms, and even dictate how physically close those terms should be to each other in the text. To really highlight the danger of basic searching, let's look at the implicit AND rule. When you type multiple words next to each other in a basic search, Web of Science automatically inserts a hidden AND between them. So typing rainbow trout fish farm is processed exactly the same as rainbow and trout and fish and farm. This means the database is just hunting for all four words anywhere in the record, completely ignoring the fact that you probably wanted them as a single phrase. This right here is a primary culprit for those surprisingly noisy and irrelevant result lists. Moving right along to Section 2, Field Tags and Wildcards. These are essentially your building blocks. Instead of letting the database guess where to look, we are going to tell it exactly where to go. The crucial point here is memorizing these two-letter field tags. Think of them as your steering wheel. For example, TS stands for topic, which neatly searches the title, abstract, and keywords all together. But if you only want your terms in the official title, you use TI. Need a specific author? Use AU. And if you're looking for research from a specific university, OO for organization is fantastic. It actually searches standardized institutional names, which completely saves you from worrying about whether an author spelled it univ or university. By just typing the tag, an equal sign, and your term, you instantly target specific metadata instead of scanning the whole paper. Now let's talk about wildcards, because these act as incredible time savers. Language is messy, right? Authors use different variations of words all the time. Instead of typing out every possible iteration, you just use these symbols. The asterisk represents any number of characters, so typing therapist instantly catches therapy, therapies, and therapeutic. The question mark replaces exactly one character, which is absolutely perfect for something like wom, n, to catch both woman and women. And the dollar sign represents 0 or 1 character. This is a total lifesaver for catching UK versus US spelling variations, like behavioral with or without the U. All right, Section 3, Mastering Boolean Operators. These are our logic connectors. Now that we have our raw ingredients, our field tags and wildcards, let's introduce the logical commands that connect them. You are likely familiar with these, but their proper application is what separates a novice from a true expert. Boolean operators dictate the relationship between your terms. And narrows your search because the database must find records containing both terms. Or broadens your search. It casts a wider net to find at least one of the terms, which is just perfect for stringing together a bunch of synonyms. Finally, not aggressively funnels your results down by explicitly excluding a term from your search entirely. To see this in action, take a look at this incredibly specific yet highly practical example. Cadmium and Gill, not Pisces. Imagine you're researching the chemical effects of cadmium on mushroom gills, but your search results keep flooding you with aquatic biology papers about fish. By slapping "not Pisces" at the end of your query, you actually save yourself from reading about literal fish when you only want chemical data on fungi. It's such a great trick.
Next up, Section 4, Proximity and Nesting. This is where we get into advanced precision.
Boolean operators are great, but sometimes we need to dictate the physical distance between words to ensure they are actually contextually related to each other. This is where proximity operators come in. Using near/x tells the database that your terms must be within a certain number of words of each other in any order. For instance, salmon near/10 virus finds those words within 10 words of each other. Interestingly, if you just type near and leave off the number, Web of Science defaults to a maximum gap of 15 words. The other operator, same, is highly specialized. It restricts your search to terms that appear within the exact same sentence or, most commonly, within the exact same author address field.
Now here is something absolutely crucial. When you start mixing near, not, and or in a single search, Web of Science processes your instructions in an exact, strict order of operations, kind of like algebra. It processes near first, then same, then not, and finally or. If you don't realize this, the database might combine your terms in a way you totally didn't intend, completely ruining your results.
But notice how we can take back control using parentheses, a technique called nesting. Look at the first example. Without parentheses, Web of Science processes the and before the or. So cancer and liver or lung gives you items about liver cancer, plus absolutely every article ever written about any lung disease, cancerous or not. By using nesting in the second example, cancer and liver or lung, you force the database to evaluate the or statement first. This correctly groups your concepts, overriding that default order, and preventing those chaotic, frustrating results. It's a real game changer.
Which brings us to our final section, building complex queries. Think of this as our workbench.
So we've learned the codes, the wildcards, and the logic. Now let's actually step into the Web of Science interface to cook up your ultimate search. The cool thing is, the database remembers your work. Every search you execute is automatically saved in your search history as a numbered set. Set 1, set 2, set 3, and so on. Think of these sets like prepped ingredients in our kitchen. You don't have to try and build one massive, complicated, error-prone string of text all at once. You can search for your disease synonyms in set 1, your treatment synonyms in set 2, and your geographic locations in set 3, completely separately.
Once all your ingredients are prepped, you use the Advanced Search Query Builder. Looking at the builder, you can just check the boxes next to set 1, set 2, and set 3, and cleanly combine them using the AND operator. The Query Builder visually constructs the final logic for you, seamlessly combining those 3 distinct searches into one masterful, highly targeted list of results. It makes complex searching remarkably clean and visual.
Furthermore, Web of Science provides some great safety nets while you work at this workbench. Note that the platform offers AI-enabled search, providing real-time topic and keyword suggestions as you type, which really helps you discover related terms you might have missed. It also features a "Did you mean?" auto-suggest built-in spell checker. However, if you want absolute strict control of your words without the database expanding them to plurals or variations, you can easily toggle exact search on to maintain total authority over your query.
Well, we have covered a ton of ground today, from field tags to nesting and combining sets. You now possess the exact syntax weapons required to defeat the monster of irrelevant data. So I'll leave you with this. What is the one impossible literature review you've been putting off? The one you thought would simply yield way too much noise that you can now conquer with these advanced tools. Thank you so much for joining me for this explainer. Now go out there and show that database who's boss.